Hi everyone. We're looking at notes 1.1 and they are on primary trigonometric ratios. But before we get to anything trigonometric related right here, we're going to talk about Pythagorean theorem. So just a reminder, I know you guys have already learned Pythagorean theorem, but we just want to do a reminder of what it is because that's going to help us out with the rest of this unit. In a right triangle, Pythagorean theorem tells us that a squared plus b squared equals c squared, okay? But we have to know what a, b, and c are. So here we have our right triangle right here, and this side right here is called c, and the name for it is called the hypotenuse, okay? And something you need to know about the hypotenuse is it is the longest side of the right triangle, okay? And then over here, this is A and this is B. But just to note, A and B are interchangeable, okay? So if I wanted to call this side B and this side A instead, I'm totally allowed to. And just so that you know, A and B are called the legs of your right triangle, okay? So if you take a look right here, it says to solve for the missing sides in the examples below. If necessary, round to the nearest tenth. So we'll talk about how to do that right now. So in this first example, one thing I just want to indicate to you is you cannot assume that a triangle is a right triangle without this right angle box right here. Okay, so now that we see that right angle box there, we can assume it's a right triangle. And what we're going to do is we're going to label each one of these sides. Now, one thing I forgot to mention is the hypotenuse is always across from the right angle. So let's actually write this down. Across from the right angle. Okay, so this right here, because it's across from the right angle, this 13 right here is called side C. So we're going to label this C. And because A and B are interchangeable, this could be A or this could be A. It doesn't matter. So we'll call this side A and we'll call this side B. Okay, so when I use the formula a squared plus b squared equals c squared, A is unknown, so we're going to leave it as a squared. B is 5, so I'm going to write down 5 squared, and C is 13, so I'm going to write down 13 squared. Now, I'm going to figure out what these values are, and I'm going to use Desmos scientific calculator to figure out what these numbers are. But I know that 5 squared is 25 when I plug that in. And if you were to do 13 times 13, because that's what 13 squared means, make sure you don't do 13 times 2. You should get 169. Now at this point we have an equation that needs to be solved. So in order to solve this equation, what I need to do is I need to get rid of this 25 somehow. So since this is addition, I'm going to do the opposite of addition, which is subtraction. So I'm going to subtract 25 from the left side, but whatever I do to the left side, I have to do to the right side. So these 25s cancel because 25 minus 25 is nothing. So I just have a squared left over. And then 169 minus 25 is 144. Now, the next thing that I need to undo is I need to get rid of this squared. And the opposite of squaring something is square rooting. So the square root of a squared is a. But whatever I do to one side, I have to do to the other. So I need to find out what the square root of 144 is. So if I go to Desmos, or if I use whatever calculator I have, if I type in square root of 144, it'll give me my answer, which is 12. Okay, so here I know that my answer is 12. It says to round to the nearest tenth, but I don't need to round because it's a whole number, okay? Or it's a terminating number. It's not a decimal that keeps going and going and going, okay? All right, so taking a look at the next example that we have here, we know that this is our right angle, which means this has to be C. Of course, it's labeled C for us, but it's not always going to be labeled for us, so we need to know which one is which. So now that we know that C is our hypotenuse, this 11 and this 12 could be A or B. It doesn't matter. So I'll call 11A and 12B. You could do it the other way around. It's totally fine. So I'm going to say A squared plus B squared equals C squared. So now A here is 11 squared. B is 12, and I have to square it. And C, I don't know what it is, so I'm going to leave it as C squared. So if I do 11 squared, it's 11 times 11, which is 121. If I do 12 squared, that's 12 times 12, which is 144. And I still don't know what C squared is. Now notice how I'm copying this down every line because it's important that you are communicating your mathematical reasoning clearly. Okay? So right here, the next thing that I need to do is I need to determine right here what 121 plus 144 is. On this side right here, because, in this example, because the 25 and the 169 are on opposite sides right here, I couldn't put them together. But since these are on the same side, I can just go ahead and add them together. So it's going to be 121 plus 144, and I end up getting 265. So here I can just type in write down 265 equals C squared. And now the C is alone. Notice right here, you cannot square root until that A squared or that B squared or that C squared is completely alone. So I'm going to square root both sides to get the C out of there without the squared. And in order to do that, I have to square root the 265 here as well. So I'll press enter here. Square root of 265 ends up being 16.278820, and it actually keeps going. So what we're going to do here is we're going to write down that it's approximately right here 16.278820, I believe is what it said, if I remember correctly. Yep, so it says to round to the nearest tenth. If you remember, this is the decimal place right here. This is the tenths place. So I look and see what comes after. It's a 7. If it's 5 or above, you give the place that you're trying to round to a shove up. So this 2 gets shoved up to a 3. And that's my answer, rounded to the nearest tenths. Okay? So now before we get into trigonometry, there are 3 different words that we need to make sure that we understand for trigonometry. So the first word is adjacent, and adjacent just simply means next to. Okay? The next one that we need to look at is the word opposite, and opposite is just across from the angle. Okay, when we say adjacent, we're saying adjacent to the angle. Okay, and then the last one is the hypotenuse, which we already have talked about at the beginning of this video. So the hypotenuse is across from the right angle. Okay, these ones are not the right angles. So if you take a look right here, it says find the length of the side that is adjacent to angle A. So if you take a look at angle A right here, it can't be the 5 because the 5 is the hypotenuse because it's across from the right angle. Okay, so it's either the 4 or the 3. Now, notice how the 4 is actually touching the angle. So the 4 right here has to be adjacent to angle A, as opposed to the 3, which is across from angle A. So the one that's adjacent to angle A is has a length of 4. Now, the one that is opposite angle A, we're going to skip this one right now. We're going to do opposite angle A, has to be 3 because it's the one that's across from it. So this one is going to be 3 right here. Okay? Now that we've done that, let's take a look at angle C. So angle C right here, the angle that's opposite angle C has to be across from it, so that is 4. So the one that's opposite angle C is adjacent to angle A, just so that you know. Okay, and then adjacent to angle C means it's next to it, so it has to be the 3. And then lastly, we have the hypotenuse, which we said is across from the right angle, so it's always going to be 5. Now, it's a little bit confusing about the hypotenuse because technically this side is adjacent to angle A and adjacent to angle C because they're next to it, but the hypotenuse can never be the adjacent. Okay? So now we're going to look at what trigonometry is. So if you take a look here, it says trigonometry is the branch of mathematics that deals with the relationships between the sides and angles of triangles and the calculations based on them. Okay? Now, with right triangle trigonometry, what's really important for you to know is that the ratios of specific angles are constant. And we're going to talk about what this means, if we haven't already, in class together as a group. Because it's really important you understand what the trigonometry means and what these values actually are. So we're going to do a little discussion of it in class so you fully understand what trig actually is. So now that we've discussed it, the ratios of specific angles are constant. These three terms right here are the ratios. Okay, so these are the ratios. Okay, now this is sine of x. Please do not call it sin of x because it's sine. This is cosine of x, and this is tangent of x. And all three of these have their own specific ratio, and it's based on these three words: adjacent, opposite, and hypotenuse. Okay, so sine of x is always going to be opposite over hypotenuse. Always. Okay. The cosine of x is always going to be adjacent over hypotenuse. And then the tangent of x is always going to be opposite over adjacent. Okay? So if you remember the mnemonic device SOHCAHTOA, that's where this is coming from. So I like to write SOHCAHTOA out like this. Some people just write SOHCAHTOA like this. It's totally up to you how you want to do it. But I like to write it like this because then you see that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, so A over H. And tangent is opposite over adjacent, or O over A. Okay? All right, so if you take a look right here, it says fill in the following blanks in ratio form. Ratio form means as a fraction. So the first thing we're going to do, every time we have a trig problem, a right triangle trig problem, we're going to write out SOHCAHTOA because that's going to help us out. Okay, so if you take a look right here, the first thing it asks us to find is sine of x. So we're going to use x right here. Please use a pencil for this because we're going to write over this and then we're going to erase it. Okay, so sine of x, here x is our angle right here. So we're going to label opposite, adjacent, and hypotenuse based on that information. So if you take a look right here, the side that's across from the right angle is always going to be the hypotenuse. So I'm going to label this H. The 9 is touching the angle, so it's adjacent to angle X. So this is A. And the 40 is across from angle X, so this is opposite. Okay, or O. So sine is opposite over hypotenuse. So the opposite is 40, the hypotenuse is 41. So this is going to be 40 over 41. Okay, next thing we're going to do is cosine of x. And since cosine of x is adjacent over hypotenuse, we know adjacent is 9, and we know the hypotenuse is 41. So it's 9 out of 41. And then lastly, we have tangent of x, and we know tangent is opposite over adjacent. So we know the opposite is 40 and the adjacent is 9. So tangent of x is 40 over 9. Okay? All right, so now that we've looked at that for sine of x, let's go ahead and do the same thing for, now that we've looked at it for angle x, let's go ahead and look at it for angle z, or angle z, okay? So if I take a look right here, I'm going to erase this stuff right here, and I'm going to relabel it because now it's based on a different angle, this angle right here. So first of all, this 41 is still the hypotenuse because it's across from the right angle. So now this 40 is now the adjacent because it's next to angle x, or angle z, excuse me. And this 9 right here is the opposite because it's across from angle z. Okay, so to find sine, we need to do opposite over hypotenuse. And we know the opposite is 9 and the hypotenuse is 41. So it's 9 over 41. Okay? To do cosine, we know it's adjacent over hypotenuse. So we know adjacent is 40 and hypotenuse is 41. So it's 40 out of 41. Okay? And then to do tangent, we know tangent is opposite over adjacent. So opposite is 9, adjacent is 40. So it's 9 out of 40. Okay? All right, now question number 2 says to fill in the following blanks in decimal form. So same thing, first thing we want to do is we want to write out Sohcahtoa. Okay, and here we know that angle B right here is what we're trying to find, sine of B, cosine B, tangent of B. Everything's based on angle B right here. So if you look right here, we know that the 15 is the opposite because it's across from it and it's not the hypotenuse. The 8 is the adjacent because it's right next to it right here. But something is missing. We don't know the hypotenuse. So we know this is h, but we don't know the actual number for it. So this is where Pythagorean theorem is going to come into play. So a squared plus b squared equals c squared. And we know that the hypotenuse is the c, so we don't know the c, so we're going to leave this as c squared. And a and b are interchangeable, so it doesn't matter. So I'll say a is 15 and b is 8, but if you want to do the opposite, that's totally fine. Now 15 squared is 15 times 15, which is 225. 8 squared is 8 times 8, which is 64, and that's equal to c squared. Now, since these are on the same side, I can add them together. So 289 equals c squared, and the opposite of squaring something is square rooting. And if I were to plug in the square root of 289, I know that that is 17. Okay? So right here, I'm going to say this is equal to 17. So now we know that c is 17. Therefore, we can go through and figure out all of our answers. So sine of b right here is opposite over hypotenuse. So the opposite is 15 right here, and the hypotenuse is 17. So it's 15 out of 17. We know the hypotenuse is 17. But it says to do it in decimal form and round it to the nearest thousandth. So right here, I have to type in 15 divided by 17 right here and press enter, and I end up getting this crazy wacky number right here. But it says to round to the nearest thousandths. So this 8 is the tenths, this 8 is the hundredths, this 2 is the thousandths. The 3 that comes after the thousandths, because I always have to look at the place that comes after the one I'm rounding to, says to keep the 2 the same. Because remember, 5 and above, give it a shove. Everything else, just keep it the same. So that means that this 2 is my is going to stay the same, and that's why I cut it off, because that's the thousandths place. So right here, my answer is 0.882. Okay? Now for cosine of b, cosine is adjacent over hypotenuse, so it's 8 over 17. Sorry, this is approximately because we're rounding it, okay? So I'm going to do the same thing. I'm going to type in 8 divided by 17 into my calculator, and I end up getting 0.4705, blah, 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 blah. Tenths, hundred, thousandths, I'm going to go to the thousandths place. This is a 0. This is where it gets cut off, but I look at the 5. 5 and above, I give it a shove. So if this is a 0, 1 above 0 is 1. So right here, my answer is going to be 0.471. And then lastly, to do tangent of b, it's opposite over adjacent, so it's going to be 15 over 8. Okay? And when I type that into my calculator, 15 divided by 8, okay? Sorry about that. Let's try this again. 15 divided by 8. I get 1.875. It stops in the thousandths place, no need to round. So I get 1.875, and I'm good to go for that. Okay? Now I want to take a look at angle C. So this 17 is still the hypotenuse, but now this 8 becomes the opposite because it's across, and the 15 now becomes the adjacent because it's touching that angle C. So to find sine of C, it's the opposite over the hypotenuse, so the opposite is 8, and the hypotenuse is 17, so I'm going to type in I'm going to write down 8 over 17. And the good news is we already figured out what that is. We figured out it's 0.471, so we don't have to type it in. For the cosine of C, remember cosine is adjacent over hypotenuse. So adjacent is 15 now over 17. So here we've got 15 over 17, which we already calculated is 0.882. Okay, and then lastly, to do tangent, it's opposite over adjacent. So now the opposite is 8 and the adjacent is 15, so it flipped. They switched with each other. So here I'm going to do 8 over 15, and I'm going to type that into my calculator because we haven't calculated that one yet. So 8 divided by 15, and I end up getting 0.53 repeating. So I go tenths, hundredths, thousandths place. What comes after the thousandths is still a 3, so I keep this 3 the same. So this is approximately 0.533. Okay? Lastly, question number 3, find the following rounded to the nearest hundredth. Okay? So in order to be able to do this, the first thing I need is my calculator. So the first question we have is sine of 35. First of all, you have to make sure you are in degree mode. Okay? So I'm going to type in sine. I'm going to type in 35, and I get this answer right here. So if I need to go to the hundredths place, this is the tenths, the 5 is the tenths, the 7 is the hundredths. I look at what comes after. It's a 3. It's not 5 and above, so I keep it at I keep the 7 the same. So I get approximately 0.57. Now, if you're having troubles with your calculator, because each calculator might work differently, just let me know and I'll help you figure out how to type it in correctly into your calculator. Okay? The next value that we have is sine of 30. So same thing, I'm just going to type in sine of 30. Press enter, I get 0.5. No need to round because it's an exact answer, and there we go. Next thing I'm going to do is cosine of 68. So type in cosine 68, press enter, I get this value right here. I'm going to type in, or I'm going to look at the 7. What comes after the 7 is a 4. So the 7 stays the same because it's not 5 and above. So I get approximately 0.37. Okay? Then I'm going to type in cosine of 30. So the cosine of 30, close my bracket. I end up getting this value right here, 0.866, so on and so forth. The hundredths place is the first 6. The 6 after tells me to give that first 6 a shove up, so I get approximately 0.87. Okay? Next one is tangent of 82. So I'm going to write tan of 82 in my calculator, press enter. I get this value right here, 0.7, sorry. 0.711, so on and so forth. I look at the second one because that's the hundredths place. There's a 5 after it. 5 and above tells me to give it a shove. So it's 7.12, approximately. And then the last one I have is tangent of 30. And I'm going to close my bracket. And here I get this value right here. The first 7 is the hundredths place. The second 7 tells me to bump that first 7 up to an 8. So I get approximately 0.58. Okay, and that's it. So let me know if you have any questions, and I hope you have a wonderful day. Bye.